So I'm going to tell you a bit about containers today, and it's based on a real-world experience I had. I started 3 years ago. I was lucky to be the member of a team that brought containers to production on a fairly large scale here in Australia. So I'm going to talk about my experience. But first, let me tell you about who I am. I'm a senior consultant for a company called Avocado Consulting. We have a booth in the main section, so come and have a chat. I do DevOps. We do DevOps, automation, engineering, operational intelligence, application performance monitoring, services in all those areas. You could say the kind of cutting-edge stuff. I have a background in rather in infrastructure, so I come more from the ops side of DevOps than the dev side. And about 5 years ago, I operated a bit of a shift towards automation and APM because this is just the trend of the industry. This is where this is all going. So it was a container spotted in the wild. So I think that despite the maybe the hype around containers, they are not that common in production. And maybe I'm going to get proven wrong, but how many of you run containers in production? I see about 5, 6 hands. So that's, yeah, I think that's about right. It's about right because I found these statistics. So this is from a company called Datadog. Maybe some of you use their services. It's a SaaS monitoring company. You basically install agents on your infrastructure, and they ship the instrumentation to the Datadog website. And they know what their customers run in production because they monitor their platforms. And what they found, and that was published in June 2016, is that Docker adoption went up 30% in a year. And what this graph doesn't show, but there's another graph on their website, is that 10% of their customers now run Docker in production. So it's about right, about 10%. So we're really not, even not even at the 50% mark for adoption. But before I'm going to talk about containers and the experience I had with putting them into production, I would like to talk about DevOps. Because I think that if you want to be completely successful with containers, you do have to adopt DevOps principles. In a way, they go hand in hand. And DevOps seems to be taken for granted these days. Everybody has heard the term. I think everybody thinks they've been implementing it, but I don't think it's really often implemented fully. So I'd like to maybe go back to the origin of DevOps. So DevOps is different from automation engineering. A lot of people have implemented, that's what I see the most as a consultant when I talk to customers. They have automation around provisioning platforms, around provisioning servers. But it's not the full story. There's a lot more to DevOps than just automating platforms. And I actually see a lot of platform teams being renamed to DevOps team, which I think is a bit wrong. I think DevOps is a transversal culture shift. It should span your entire IT. It should even spill over the business. Everybody should be part of it. And it needs buy-in from the entire organization. You can't just push DevOps, from your team or your corner. I think management has to buy it in. So where does it come from? The Dev and Ops dichotomy. Devs are agents of change. Indeed, the role of developers is to bring new functionalities. It's to bring changes to applications. Their interest is to have changes deployed to production quickly. But operations are agents of stability. They are often judged on how stable production environments are. And there is a clear opposition between the two, right? So you have, on the one hand, one team that just fights for rapid changes, and on the other end, you have another team who's like, oh, hang on, I don't want to break production. Can we slow down? And in the middle, of course, you have all the ITIL stuff that has been introduced and all the change management procedures and etc. And it can lead to frustration from the business because they're like, oh, how come this change is taking like 3 months to go to production? It's really not that complicated. So that's where DevOps come from. It's about improving time to market. First and foremost, it's about velocity. And it's also about improving the resolution time for incidents. Because if you can push changes to production quickly for just new functionalities, you can push fixes quickly to production as well. So you have those two gains, and this leads to a better customer experience. That's what it's all about. It's about customer experience. And customers can be internal. It doesn't have to be customers, on the internet. It can be your internal customers. It can be your call center agents. It can be the business. It can be your BI team. Oh, by the way, the term DevOps appeared in 2009 in a conference in Europe. And some people were actually DevOps before DevOps was invented. So what are the DevOps principles? I mean, according to me, obviously there's lots of literature and lots of blog posts and what is DevOps. And so I think the first principle is collaboration between development teams and operation teams. Also collaboration between development teams and testing teams, and collaboration between development teams and the business. And everyone should be working together. That's the whole idea. And one of the first, probably tool that supports collaboration is source control. I think everyone should have access to the code. I don't see why operation teams couldn't have a look at the code. Why not? And there's also a lot of collaboration tools that you might be using, like chat and wikis and all of that. So that's the first step. It's about culture. The second very important element, I think it's the software pipeline, whatever you call it. Continuous integration, continuous delivery. It's about building software quicker. It's about deploying software quicker to various environments. It's also about testing software quicker because you can build automated testing in your CI. It's also automation. So as I said, I don't think DevOps is only about automation, but automation is, of course, a very important part of it. So infrastructure as code, which means spinning up environments quickly based on code that you write, automated testing, automated deployments. It's all automation. And monitoring, it's a very important one. It gets overlooked. One of the principles of DevOps is that you should have continuous feedback. How can you improve your software if you're not actually measuring how it performs? Well, it's very hard. So monitoring should be baked in, and I'm going to show an example later on. So 3 years ago, I was lucky to be the member of a team that was tasked to migrate a VAS platform for a big telco. So VAS is value-added services. So that's how telco calls websites where you can pay your bills or download ringtones or stuff like that. And it was an opportunity for the company to start something from scratch. So it was an opportunity for the company to have their teams work together, because the hardest thing with DevOps is, where do I start? How do I make my guys work together? So one of the ways to have operations and developers work together is on a new project. You have a new project, you're building a new platform. Well, why not build it together? Operations can contribute to the code. They can write infrastructure as code. They can work hand in hand with the developers. And that was the philosophy behind kind of this case study that I'm going to present. So it was about migrating from an old Solaris platform to a private Linux cloud. Obviously, Linux kind of owned the space of web hosting nowadays, pretty much. So the motivations were, the platform was aging, needed replacement. There was a need for faster and more fault-proof deployments. Traditional deployments were based, on a run sheet. It was like a Word document, and people would just execute things manually against every server. And obviously, it doesn't really cut it anymore, and it really doesn't cut it if you use containers. And there was a need for more elasticity. So how do I scale up automatically when I have a peak? And I'm not talking about peak that you can plan for. I'm talking about peak you can't plan for. So in order to reach those goals, the platform itself had a number of goals. So the focus was on elasticity, automation, and DevOps principles. So by that, I mean that Dev and Ops were tasked to work together on building that platform. Monitoring, continuous feedback was built in from the start, even in dev environments. And that's the part I actually worked on. And everything had to be automated. There is no I click on a button if I want a VM in that platform. Actually, there is, but it's a bit, it's about blocks of VMs, as I'm going to show. It had to be ready for microservices migration. So microservices, it's another trend in the industry where you break down your big monolithic applications into a lot of small workloads. And containers are perfect for that. There had to be identical prod and non-prod environments. So for people like me who've been in the industry for a while, having pre-prod or test environments that are different from prod were pretty common. And it is really, really hard to fix anything when you have these kinds of environments. So holistic monitoring had to be built in. And finally, it's based on immutable VMs. Is everybody familiar with immutable VMs? You know what it is? Show of hands, maybe? Yeah, okay, it's about 10%. So immutable VMs means that the VMs have a very short life cycle. The virtual machines have a very, very short life cycle. If you need to patch your environments, you don't install patches on the VMs. You just destroy the VMs, you recreate them automatically with the patch installed. When I was working on that platform, the Ghost SSL vulnerability happened. And this platform was the fastest patched in the whole organization because of that immutable VMs principle and the automation that was built. So the focus of automation, so blocks of VMs could be spun up at will through a web GUI. Each block has a virtual load balancer just baked in, which means it's ready to accept traffic. The applications had to be Dockerized because of that focus towards microservices. And the applications had to be deployed through a continuous deployment system, which was Atlassian Bamboo. So again, for deploying, there was no question of logging onto a VMs and just do things manually. Had to be done through Bamboo. And Ansible was chosen as the automation glue, and that was back in 2013. And it was kind of early days for Ansible. Not early, but fairly early. So here is a fantastic animation. So we have a management network in this platform, and the provisioning machine here just talk to VMware and say, oh, spin up a block, spin up another block of VMs, virtual F5s all across the board, so load balancers. And those VMs are immutable. Once they're deployed, they're not modified. So applications were Dockerized, and that's how they were deployed. Just start Docker containers on VMs. And then traffic can be served. So a few words about the technology choices. At the time, we evaluated a number of solutions around automation, and obviously there was one that was already established, and I'm sure a lot of you have been across it, but we tried Ansible, and it just fulfilled really our goals. The first thing about Ansible that we liked is that the YAML syntax is easy to comprehend. It's one thing to be an expert at an automation technology, but if it's really hard to explain to people who don't really know it inside out, it makes it difficult to get it accepted across an organization. So Ansible is great for that. So there's quick uptake because of the YAML syntax. It's got an agentless architecture, which is, in my opinion, a really big win. So you just configure machines through SSH connections or WinRM on Windows. It combines configuration management and orchestration, and that's a big one as well. Because configuration management, a lot of tools can do that. Combining both configuration management, which is keeping the state, and orchestration, that's something that Ansible does really well. And it's, at the time, and it's still a good match with Docker. Obviously, nowadays, 3 years on, there's maybe better ways to manage the life cycle of containers. You've heard about Kubernetes in the talk before. The next talk is about OpenShift. There's really several ways to skin a cat in that respect. Ansible is also great at integrating with CI/CD systems. So here you can have a continuous integration system that builds your application, continuously, and then through an Ansible playbook you can deploy it. And that's what we did with Atlassian Bamboo and Ansible, both integrated. It's very easy to do. Another maybe crazy technology choice in 2013 was Docker. Was it ready for production? Well, actually it was. So Docker, it's lightweight containers. It's a perfect match for running microservices. It allows for really rapid deployment and redeployment. And containers contain all application dependencies, and that's where this is a big win. So basically, when you build your applications and you want to deploy them on those immutable VMs, you don't need to make sure, if you have, the right, jars or the right dependencies, the right libraries. The containers, container images contain all the application's dependency, and they're stored into a registry. It's like an app store. So you can say, I want to take this app and deploy it onto 100 machines through using Ansible or other automation technologies. And containers allow you to do this. But you can also run containers on your development laptop. They scale from your laptop to a massive scale. So if you see companies like Google run them on a really, really massive scale. And another nifty feature is that container images can inherit from existing containers, meaning you can build containers upon containers. I'm going to show you an example of that. And there's a huge ecosystem nowadays. Even in 2014, there was a big ecosystem, but of course, nowadays it's really absolutely massive. There's so many developments around containers. And as I said, the Docker images are distributed through a registry, a bit like an Apple store. Well, in that respect, be careful with downloading images from the internet and deploying them on your mission-critical infrastructure. You have to vet them before, but that's another subject. And I want to show how Docker solved the monitoring challenges quite elegantly. So we wanted to have the same monitoring solution across the board. It had to be elastic. It had to provide state-of-the-art application performance monitoring. It had to integrate with the current monitoring solution, which was based on a HPOV. And it had to add value to every environment. Monitoring is not something you only do in production. Monitoring has value for volume testing. It has value for developers when they do unit testing. So we chose at the time Dynatrace application monitoring. So Dynatrace is a real-time profiler. By combining Dynatrace with Docker, we allowed for elasticity. And finally, a log processing solution complemented Dynatrace. And this is how image inheritance works. Is here we had a vanilla kind of empty Tomcat 7 container image, meaning that we had the Tomcat 7 binary in there, but no applications. And the Dynatrace agent was built in this container. And then developers who worked on Tomcat 7 applications would inherit this container and just add their application on top. Which means that there's only, the maintenance is really simpler, because when you need to upgrade to a new version of Tomcat, you just upgrade the parent container and then rebuild your containers and just redeploy them automatically. And the Dynatrace agent could be built in, meaning that across the board, in dev, in test, in volume testing, in pre-prod and in prod, we had Dynatrace monitoring, where all our containers here sent instrumentation data to Dynatrace collectors, which is a bit like a middleware for Dynatrace, and then back to the server for consumption. And having the same monitoring solution built inside your containers from the ground up is a great thing, because you can use it in dev for doing your unit testing, making sure the new version of your application isn't breaking stuff. You can use it in volume testing for the same reasons. You can use it in production for alarming, and in production for diagnosing problems. And if operations and devs use the same monitoring solution, it fosters collaboration. So we're back to collaboration. They can collaborate on building the platform. They can collaborate on monitoring the platform and work together. So that's one way of reaching another DevOps goal around collaboration. So the overall solution benefits that we had an elastic platform ready for microservices migrations, strong cooperation between dev and ops, and monitoring solutions that spanned every environment. So that was back in 2013. The platform is still in production today. It went into production in November 2014, so exactly 2 years ago. So did it fulfill the vision 2 years later? What worked well was the technical bits, which meaning the fast deployments, the stability, the ability to patch quickly was great. What we discovered, though, is that anything related to change management, your processes might have to be tweaked. If you want to be quick about deploying stuff, but it takes 7 days for a cab to decide if a change can go in or not, then you lose the velocity. So you have to adapt change management. And it can be hard if you spent 10 years implementing ITIL a certain way, and you're very, very careful about every change in production. But I think that's something you have to talk about. it's not only about kind of cool and funky technical solutions. It's also about changing maybe the way your organization works. And I'm done.